This is a new conservat Lagerstätte that you might not have seen yet, so it's an introduction to that, and a rather extraordinary biological event that somehow has been missed up until now, and also an explanation for it which we think means that you should be able to find the same thing no matter where you are in the world. So it's really quite surprising. So the beds we're looking at are in the middle Metabolograptus presculptus biozone at the very end of the Ordovician. So we have the Hirnantian glaciation with the onset of the extinction event here, and then a second pulse of extinction during the transgression as the ice caps melted. And then we have an interval in the very latest Ordovician where virtually nothing is happening. Some of the plankton's starting to rediversify, but all the benthos really starts to diversify in the early Silurian. In this interval, you normally don't see much at all. So we're going to go to China. If you're not used to the geography, Zhejiang and places like that are over here. We're down in the eastern part of South China in Zhejiang province, and the sites that we're looking at are scattered over about 10 kilometers around a large reservoir. So it's a rather nice place to work. Luckily, they even drained the reservoir for us. Well, not quite for us, but still. But usually we have, road cut sections where you have hundreds of meters of Hirnantian sandstones. It's a very thick sequence of low stand fleisch deposits with sandstone, and then about a 10-meter interval of black mudstone, which then shallows again into sandstones. And it's this interval which occurs across several sites in the area where we get quite a lot of fossils. It's incredibly productive. Apart from the tens of thousands of graptolites, this was 1 week of collecting and we were throwing things away. Everything there, apart from some of the graptolites, is exceptionally preserved. It's extraordinary abundance for this time, and what we get is dominated almost entirely by sponges. Sorry, you can all fall asleep now. Not really. We have an extraordinarily diverse fauna. In the first week, we had 75 species, more or less. I mean, haven't done the full taxonomy yet, but that's our estimate. And to give you an idea, there were 3 species described from the entire Hirnantian worldwide until we found it. So 75 species of sponges. We have different species at different levels. There's a lot of good skeletal preservation, but most of it is actually soft tissue as well. In many cases, you can't see the skeleton clearly because there's too much soft tissue. Preserved by, when it's relatively pristine, it's this black material, some sort of iron sulfide. We're thinking maybe greigite machinawite at the moment, but needs more work to work out exactly what the taphonomic pathway is. We've got a mixture of ancient and derived groups. And aside from these thousands of sponges, we had about 5 nautiloids, no brachiopods, no trilobites, no other mollusks, and 1 Eurypterid. This is the first Ordovician one from China, so some people there are quite interested in it. But we've got, it's not complete and it's very badly weathered, but it is articulated. You've got the various limbs, you've got the paddle sticking out. It's really rather nice. So we're not just seeing the exceptional preservation in the sponges, there's potential for an awful lot more here. We've since been back and done more, as you would imagine. Another week, the diversity is now well over 100 species, we think, just of the sponges. We've got new sites, we've got more diversity within the sites that we've collected, and we can confirm that there are other exceptionally preserved fossils there as well. It's not just the sponges, although they do dominate completely. So, I don't want to bore you with all of the details of the taxonomy, but there's 1 or 2 sponges I just want to mention. This one in particular is really exquisitely preserved details of the skeleton down to quite a fine scale. The whole thing is a couple of centimeters across in this view. We have diagnostic spicules of projecting hypodermal pentactines going through the body wall like a veil. And we even have 1/10 of a millimeter wide microscleres, all of which allows us to present to interpret it quite in a detailed way. And it basically appears to be crateromorpha. Including these microscleres, we've got 4 different morphologies, which seem to be diagnostic of 1 subgenus. The problem is that these things aren't meant to have evolved until the Cretaceous, say. We haven't just got the one of them, we've actually got about a dozen different modern hexactinellids representing families of the euplectellids, rossellids, leucopsacids, a whole suite of things which should not exist at this time. And most of these have no fossil record at all. Some of them have, from the Cretaceous onwards, no other Paleozoic record of anything resembling these at all. So there is something very, very strange going on here. We think we're looking at a deep water fauna that's normally on the abyssal plain and doesn't quite make it onto the preservable areas of the shelf. So it's telling us that there's an awful lot going on, probably in hidden deep water environments with extremely early diversification. Okay. There are new sections. This is one of the most interesting ones, where we actually have a little shelly fauna, Hydromanella type, so it's sort of Hirnantia fauna effectively at one end, sponge dominated from about here upwards, and between them we've got an intermediate bit where there's other things. So we actually have some echinoderms, for example. And articulated echinoderms at this time are not very common, but I mean, we also have the odd oddity like this thing here, which is, it's a ring of plates with serrated margins and so on. It's been looked at by a few people, and there's only one plausible interpretation of this, which, hang on, no, not that one, it's got to be a radiodontid. This is obviously quite preliminary. We've only spent a couple of hours at this site so far, so we haven't gone back yet to look for the appendages, but from what we can see, we're getting fairly confident that this really is, well, apart from Schinderhannes, the latest radiodontid. So there's potential for an awful lot more to come out of here, despite the rarity of things that are not sponges, which is quite interesting. So one of the obvious questions is this unique? Is this a peculiarity of that particular site? And at about the same time as we were working on this, Li et al. Described a fauna of about 30 sponges from exactly the same interval across the Ordovician-Silurian boundary in the next province across in Anhui. It's only about 100 kilometers or so from our site. And in this case, it's a little different in that it's a condensed sequence. So biozones tend to be a few meters thick, if that, and then 2 meters full of sponges. And we've been looking a little bit more widely and now found that we can extend this sponge fauna over about 2,000 kilometers. Basically, everywhere we look across South China in the latest Ordovician, going into the Silurian, there's abundant sponges. Usually it's not articulated so far. We have exceptional preservation with soft tissues just in the eastern part, but there's bits of articulation elsewhere as well. So that was the Anji area. This is Beigong. Gangangshan is the next one. Very similar preservation, iron oxides, replacements of skeletons and soft tissues. Another condensed sequence. Biozones tend to be a meter or two thick. Then we have a 2 meter section of very rapidly deposited mudstone at the boundary, which is full of complete sponges. This is quite strange if you think about the taphonomy of that. Condensed sequences and yet rapidly deposited sponges. So, going further to the west, we have, instead of articulated sponges, usually spiculite layers. They've not been reported before, but we have pyritized laminae from the Posculptus zone upwards, which are just full of hugely abundant spicules. I mean, it's difficult to assess the diversity, but there's vast numbers of them there, and we don't find them earlier in the Hirnantian or higher up in the Silurian. They're restricted in huge abundance to the Posculptus zone and just across the boundary. Occasionally you do get bits with articulated material as well, despite it being very condensed sequences. And you also get a peak in radiolarians. We have actually radiolarites from the same interval. So we thought that surely this can't have been overlooked everywhere. So we better check the GSSP for the Hirnantian, where it's been one of the most intensely studied sites in China probably, and nobody has ever mentioned a sponge spicule. It's full of them. So once again, exactly the same sequence from after the post-glacial transgression, hugely abundant spicules and even articulated sponges. You can't collect from the section itself, so we just spent a couple of hours looking at the loose blocks on the bottom and correlating them to the section by the graptolites. And we have things including rossellid-like sponges with these projecting hypodermal pentactine spicules as well. So even in sites which have been intensely studied on very fine detail, people have missed the sponges. So, are they everywhere? What we're left with is enormously abundant sponge moraines over the whole of South China, as far as we can make out. Every site we go to, we find them. Exceptional preservation in various places, particularly associated with this deep basin in the Anji area, but also in areas relatively close to land over towards the west. Well, the further away you go from land, the less likely you are to have exceptional preservation. But you still see the signature of hugely abundant sponges in these spiculite layers. So, trying to interpret how this all goes together, there is only, I think, one way of really explaining this, particularly the articulated sponges in condensed sequences, which is that we have effectively nepheloid layers. So we have this period of low stand, where the Yangtze platform is now quite shallow water, but it's a long way from land in the north. There's no sediment coming in from this side effectively. Cartesian landmass in the south is generating a lot of sediment, and the land area there is being weathered during the low stand. During the transgression, this suddenly is all flooded, and you have huge amounts of suspended particulate material being washed into the basin, some of which is deposited as these thick flash deposits, but a lot of it is transported across the basins towards the shallower layers and deposited en masse as nepheloid layer suspension fallout. So that explains how you can get very condensed sequences with 2 meters of mudstone very rapidly deposited. It's a working hypothesis at the moment, and there's only so much I can tell you at the moment, but because of the time limit. But just to finish off, the implications seem to be that we have, at least across South China, extraordinarily diverse sponge faunas in the aftermath of the second biggest mass extinction. They didn't even notice there was a mass extinction happening. They've actually been more diverse than they were before it, as far as we can tell. The abundance is enormously high. They seem to have taken over the shelves entirely. They're not there exclusively of anything else. There are other fossils there. We have other arthropods, bits and pieces here and there, but the other organisms are extremely rare. It's basically ecological takeover. Preservation dependent on transgression flooding of the nearby shelves, also bringing in lots of nutrients at the same time, which means that that should have applied not just here, but very widely across presumably other continents as well. Anywhere you have a relatively restricted basin area with land areas that were weathered during the low stand and then flooded should generate the same sort of patterns. And I don't believe that everyone would have seen them if they're there based on what we saw at Wang. So thank you very much.